So for Al, this morning in our class, we talked about how if we kept the same area, okay, we talked about yesterday's task was to think about what if we kept the area the same? Could we change the perimeter? So what we did yesterday is we looked at what could we do with an area of 12 units squared. So here I have an area of 12 units squared. Currently, the perimeter is 16 units. I know that the perimeter is going to be 16 units because I can measure it. I have 2 units this way, and I have 1, 2, 3, 4, 5, 6 units this way. If I have 2 rows of 6 units, then I can find the area by doing 2 units times 6 units equals 12 units squared. So that's the area that I'm looking at there. Let's just erase that for right now because we're going to play around with this a little bit. Is there a way that when I look at this, that I can keep the area the same, but use a different perimeter, have a different perimeter? So the perimeter here, we've got 2 units this way. We have 6 units this way. Whoops, not a very straight line, but that's okay. That means that the perimeter, if there were a fence around the outside of this whole thing, it would be the same as 2 units plus 2 units plus 6 units plus 6 units. I know that 2 plus 6 is 8, and I need to add another 8 units, so it gives me the area of 16 units here. Okay, so now what we're going to do, I'm going to see if I can't click off this pen. I don't want to use it anymore. It's still on. Oops, that's not what I wanted to do. I don't want to print anything. I don't know if you saw that. Just go back to this. That should work. Okay, so I have an area of 12 and a perimeter of 16. I can keep that area of 12 the same, but change the perimeter. You can see that just by moving that one square, just by moving it, that I've changed the perimeter to 18 units. The reason that the perimeter is 18 units is because I have more sides of this square exposed now. What would happen if I moved this square? Still 18 units, but what about if I moved this one too? And this one? Now we're up to a perimeter of 20 units. Our area has stayed the same. Today's problem is the opposite of this. We don't want to keep the area the same and change the perimeter. We want to keep the perimeter the same and change the area. In today's problem, you had a certain amount of fencing. But I want to start with considering maybe a different amount from the one that was in our problem today. So let's consider that we have 12 units of fencing. In the problem that you're doing with Molly Weasley, we have 25 units of fencing. I could use my 12 units of fencing like this. I see that. I can have a perimeter. Remember, fences go around the outside of a shape, so it would be perimeter. I could have 12 units of fencing and create 5 square units of area for Molly Weasley to play in. I wonder if I could make that number even bigger by using my fencing differently. What would happen if I moved this square over here? I still have 12 units of fencing. I still have 5 units of area, so that really didn't make a difference. Now I have 10 units of fencing. I still have 5 units of area. I wonder what would happen if I added another unit of area. You can see now I still have 10 units of fencing, but I have an area of 6 square units. What would happen if I added a little bit more? So you can see that with 12 units of fencing, I could have only 5 units of area, or I could have 7 units of area. Which one would be better for Molly Weasley? Obviously the bigger one. She'd rather have more room to move around. We can show that as well on a split screen. So I can use my 12 units of area. Sorry, not area, 12 units of perimeter like this. Or I can use my 12 units of perimeter, my 12 units of fencing like this. Even though my area isn't quite as long, it's definitely a lot wider. You can see here that Molly Weasley's got 3 spaces or three parts of her pen that are twice as wide as this part of her pen right here. So I can keep the perimeter the same and experiment with the area. This morning in our lesson, we talked about how the closer a shape gets to a square, the bigger the area is going to get when the perimeter stays the same. Your job today is to see with 25 units of fencing, that means 25 bits that go around the outside, 25 units around the outside measured in 1D shape. How can we arrange that differently so that we give Molly Weasley the biggest possible area? Whoops, that's not going to let me do that. But this is the area here. Whoops. Nope, it's moving it for me. I'm trying to just show you the area here. So imagine that I'm coloring that all in. I'm covering that whole bit. So we're trying to give Molly Weasley the biggest possible area that we can using 25 units of fencing. That's your job today.